So hi everyone, today we have this D and F block elements and one more class, right? We'll have it for the coordination compounds this week, so that on the coming Sunday, right, we'll plan for one session on all inorganic chemistry reactions alone. Just know the reaction based questions on all inorganic chemistry chapters, starting from S block, hydrogen, P block 13th and 14th, P block 15th to 18th, and then D and F block. So that we'll do after we complete the coordination chemistry. So we'll start with the questions. Let's look at the questions here. We have the first question. So look at the first question. Hi Karthikeyan. So look at the first question, guys. What is the first question? On addition of small amount of KMnO4. So in D and F block, we have scope for both reaction based questions as well as the reasoning based questions, and sometimes we can even have questions on the trends, etc. So look at the question. On addition of small amount of KMnO4 to concentrated sulfuric acid, a green oily compound is obtained which is highly explosive in nature. Identify the compound. So the reactions of KMnO4 and reactions of K2Cr2O7. So these manganese, potassium permanganate and potassium dichromate reactions are important ones. So check this one out, guys. The reaction between KMnO4 and concentrated sulfuric acid. What is the explosive compound that is formed? Question number 1. What is the explosive compound that is formed by the reaction between KMnO4 and concentrated sulfuric acid? I think we are getting some responses. Trisha, you are saying option C. Okay, look at this one, guys. KMnO4, when it is reacting with sulfuric acid, right, it will be forming Mn2O7. So this Mn2O7 is the explosive substance. So this is the substance that has got the explosive nature. So what is the answer for this one, guys? Option A. So when you have KMnO4 reacting with the concentrated sulfuric acid, so we'll have a green oily color compound that is formed, which will be having explosive characteristics. And what is the compound that will have explosive characteristics? It is Mn2O7. Check it, guys. So the D block and F block, right, we have to go through all the reactions in the NCERT textbook. Let's look at the next one. So these questions are also important. The questions based on the calculation of the spin-only magnetic moment. So what is the formula for the spin-only magnetic moment? Root of n into n plus 2 Bohr magneton, where n is the number of unpaired electrons. So look at this one. The magnetic moment is associated with its spin angular momentum as well as orbital angular momentum. So if you look at the magnetic moment, it will be associated both with the spin magnetic momentum as well as the orbital angular momentum. The spin only magnetic moment value of Cr3 plus ion is given by chromium 3 plus ion. What is the spin only magnetic moment value? So we have to find what is the spin only magnetic moment value. First we should know what is the number of unpaired electrons. In this formula, n represents what? Number of unpaired electrons, right? In Cr3 plus, we have to find what is the number of unpaired electrons. First we should know what is the chromium electronic arrangement. If you know the chromium electronic arrangement, means from that we can find what is the Cr3 plus electronic arrangement. 2, I think we are getting some responses. So Karthikeyan, you have to check it once. Trisha, you also have to check it. So what is chromium ground state arrangement? 3d5 4s1. What is the ground state arrangement of chromium? It is 3d5 4s1. So we are looking at the D penultimate D subshell as well as the outermost S subshell. So Cr3 plus means after losing 3 electrons, right, it loses electron from the 4s and 2 electrons from 3d. So remaining is what? 3d3 arrangement, means as per the Hund's rule, right, how we are going to fill them? Each of these will be having 1 electron. So the number of unpaired electrons is what? 3, means root of 3 into 3 plus 2 means what? Root 15. See, root 16 is what? 4. Root 15 will be slightly less than 4. Check it up, guys. It will be slightly less than 4. What is the answer going to be? It will be 3.87 Bohr magneton. What is the spin only magnetic moment value, it is 3.87 Bohr magneton. Okay, let's move on to the next question. Look at this one, guys. This is another reaction based question. When KMnO4 solution is added to oxalic acid, so oxalic acid is what? H2C2O4, otherwise COH, it's a dibasic acid. When KMnO4 solution is added to oxalic acid solution, the decolorization is slow in the beginning but becomes instantaneous after some time. It is because of, okay, so you have to be careful, Trisha, while you're doing the calculation part, you have to be a little bit more careful. So look at this question, guys. When KMnO4 solution is added to the oxalic acid solution, the decoloration is slow in the beginning but becomes instantaneous after some time. So this is a clue. Even if we are forgetting what is the actual process happening, right? Whenever we see any reaction, if they say that the reaction is slow in the beginning but the speed or the rate of the reaction is increasing after some time, it means one of the product could be acting as an catalyst itself. So these are the examples of a product becoming an autocatalyst. The product of the reaction becoming the autocatalyst. So these reactions will be able to speed up after some time. Typically we look at examples of ester hydrolysis, sugar hydrolysis, because the ester hydrolysis reactions are acid catalyzed and the product of the ester hydrolysis is also what? Acid. So after some time the reaction will keep happening at a faster rate. So look at this, guys. In the acidic medium, right, the manganese from +7, it will be going up to +2. So in the acidic medium we will be having what? Manganese +2 ions being formed, and those manganese +2 ions that are formed, right, they will be acting as a catalyst. Check this one, guys. What will be the answer for this one? The manganese 2+ ions formed, right, they will act as a catalyst, and that's the reason why after a while the reaction will speed up. So we will see that the decolorization will be faster after a while because of the autocatalysis. Clear, guys? Let's go to the next one. So this is another important area of questions, the acidic, basic and amphoteric nature of oxides. So here we are given a collection of oxides. We have Mn2O7, oxide of manganese. Chromium, we are given 3 oxides, CrO3, Cr2O3 and CrO. Vanadium, we have 2 oxides, V2O5 and V2O4. So we need to conclude which of the following will be amphoteric oxides. Question number 4, what do we need to find out? We have to find out which of them will be amphoteric oxides. So if you look at the oxides of any particular element, like say for example, we will talk about the vanadium. So if you look at vanadium, as the oxygen content is increasing, as the content of the oxygen is increasing, the oxides are going to become more and more acidic. So as the oxygen content is increasing, right, this is the thing we can remember, as the oxygen content is increasing, right, what is going to happen? The oxides are going to become acidic. So we can see V2O3 is what? It's a basic. V2O4, it's basic but less basic. Whereas V2O5, when it comes to V2O5, it will be what? Amphoteric. So we know that V2O5 is amphoteric, means option B is not going to be the answer. Either it is A, C or D. Now we are given 3 oxides of chromium. What are these? CrO3. CrO3 is the acidic anhydride of chromic acid. What is chromic acid? H2CrO4. So if you remove water molecule from this, means what we are going to get? CrO3. CrO3 is the acidic anhydride of chromic acid. So CrO3 is what? Acidic. Cr2O3 will be amphoteric. Again, the idea is when we have the oxides, right, as the oxygen content is more, they will become what? Acidic. Oxygen content less means they will be basic. So in fact here, if you look at CrO, the CrO is going to be what? Basic. CrO is going to be basic in nature. Okay. So here we are getting both Cr2O3 and V2O5 having the amphoteric nature, and Mn2O7, right? Mn2O7 is also acidic. Mn2O7 is also acidic. So in whichever oxide the oxygen content is more, that will be what? Acidic in nature. As the oxygen content is decreasing, we will slowly move to amphoteric and then we will go to basic. Clear, guys? So what is the answer for this one? It is option A. Let's move on to the next question. Which of the following compound is colored? So here we are talking about the colored nature of compound based upon the existence of unpaired electrons. We are talking about the colored nature of the compound based upon the existence of unpaired electrons. Look at the question, guys. What are these compounds given to us? TiCl3, FeCl3, CoCl2. TiCl3, FeCl3 and CoCl2. If you look at this, right, what are the respective ions we are having? We are having Ti3 plus ion. What is the arrangement of Ti3 plus? The titanium comes after scandium, right? So what is it? Argon 3d2 4s2. If you are removing 3 electrons means it will become what? It will become argon 3d1. That is the arrangement of Ti3 plus. It has got one unpaired electron. If you look at Fe3 plus, okay, so Fe3 plus is what? Fe3 plus will have an arrangement of argon 3d5. It will have 5 unpaired electrons, because we have to check what is the normal arrangement of iron. Iron is what? Argon 3d6 4s2. After removing 3 electrons it becomes what? 3d5, argon 3d5. Then cobalt 2 plus. So cobalt 2 plus is what? It will be argon 3d7 4s2, that is cobalt. After removing 2 electrons means it becomes what? Argon 3d7. I mean, if you go by the Hund's rule of filling up of these electrons, 7 electrons means first we will fill 1 each and then we will start pairing them. It will be having how many unpaired electrons? 3 unpaired electrons. So we will see all of them are having unpaired electrons. Ti3 plus is having unpaired electrons, Fe3 plus is having unpaired electrons, CO2 plus is also having unpaired electrons. So the color is because of the existence of the unpaired electrons. So what is the answer for this question, guys? It is option D. All of them will be having color. Let's go to the next one. To obtain silver from silver amalgam. So silver amalgam means what? It's metal with mercury is called as what? Amalgam. So to obtain silver from silver amalgam, it is heated in a vessel which is made up of. So generally we have to choose the metal that will not be forming amalgam. We have to choose the metal that is not going to be forming the amalgam. So look at the question, guys. Question number 6. To obtain silver from silver amalgam, it is heated in a vessel which is made up of. So generally if you look at it, right, the metals like iron and platinum, they will not be forming amalgam. Iron and platinum, right, they will not be forming amalgam. So if you heat silver amalgam in an iron vessel, right, it is going to be forming as what? Silver. So the check it, guys. 6th one. Sixth one, we have to choose the metal that will not be forming the amalgam. Okay, let's move on to the next question, guys. So some of these, we have next chapter coordination chemistry, but these D block and F block elements, to a large extent, they can form these mixed salts, and one of the very popular example is this Mohr salt. Okay, so we can even have these kind of straight questions on the names of these mixed salt. Look at this, guys. What is the question we have over here? What is the Mohr salt composition? Straight question. What is the Mohr salt composition? So we can answer this question if you know the formula. If you are not aware of the formula means we will not be able to even guess it. So these are memory based questions, guys. We have to be careful about these things. Mohr salt is mixed. Mohr salt is, I'm not getting any response so far. Okay, Anyway, look at this guys, more salt, right, is a mixed salt of ferrous sulfate and ammonium sulfate, hydrated. So what is the formula? FeSO4 dot NH4 twice SO4 dot 6H2O. What is more salt guys? FeSO4 dot NH4 twice SO4 dot 6H2O. We have to exactly remember the formula. Okay. So I think we are able to get the responses. 7th one is A. Let's go to the next question guys. Question number 8. In which of the following cases the stability of two oxidation states is correctly represented? Means we have to check the order of stability. We have to check the order of stability and we have to conclude which of them is correctly represented. Question number 8. So how do you conclude the stability part guys? We have to go to the electronic arrangement. So we will get a clue about the stability only based upon the electronic arrangement of these ions. If you have a half-filled D structure, then definitely that will be more stable than any of the nearby arrangements. Eighth, I think we are getting some responses. Check it guys. Mn2 plus, right? What is the arrangement of Mn2 plus? Mn2 plus will have what? It will be having a 3d5 stable structure than Mn3 plus. 8th, look at this guys. Mn2 plus will have what? Mn2 plus will be having a 3d5 structure. Because what is manganese arrangement? Argon 3d5 4s2. If you remove 2 electrons means it becomes what? 3d5. That will be a stable arrangement than the Mn3 plus. Look at this guys. What is the answer for this option? B is the answer. Let's go to the next question guys. Which one of the following is diamagnetic in nature? Means we have to find out which of them is a diamagnetic ion. So when we will have the diamagnetic ions, diamagnetic will come when there are no unpaired electrons. So if there are unpaired electrons means we can have a paramagnetic nature, and in specific cases we can have ferromagnetic nature or the other types of magnetic behavior. So here we have to look at which of them will have diamagnetic nature, means which of them is going to have 0 unpaired electrons. Check it guys. Question number 9. If we look at scandium, right? Scandium, what is the normal arrangement? Argon 3d 1 4s2. That is scandium, first element of the 3d series. What is scandium guys? First element of the 3d series, right? 3d1 4s2. If you look at scandium 3 plus, right, means we have to remove the 2 electrons of the 4s and 1 electron from the 3d. Remaining is what? Just argon. Means it will not have any unpaired electrons. So check this one guys. Scandium 3 plus, right? 0 unpaired electrons means what? That is going to be diamagnetic. Let's look at the next question. Question number 10. Question number 10. So this is about the comparison between the lanthanides and actinides. Look at the question guys. The larger number of oxidation states of actinoids than those by the lanthanoids. Actinoids can show larger number of oxidation states than the lanthanoids. So we have to look at what is the reason for that. We have to look at what is the reason for that. Why the actinoids are able to show higher number of oxidation states than the lanthanoids. Question number 10. Lanthanoids means what? Lanthanoids means it is the 4f series. The corresponding adjacent d orbitals are what? 5d orbitals. If you look at the actinoids, right? Actinoids, it is the 5f series. The corresponding adjacent d orbitals are what? 6d orbitals. So what is the reason why we see a higher number of oxidation states for the actinoids is because the energy gap between the 5f and 6d will be lesser. So the energy gap between the 5f and 6d is lesser than the energy gap between these two. So here we'll have a large energy gap and here we'll have a small energy gap between the 5f and 6d. That is the reason. It is not about the diffused behavior of 4f orbitals. It is not about the reactive nature. So what is the reason for this one, guys? Option B is the answer. The lesser energy difference between 5f and 6d, right, will allow the electrons, because when you can get maximum number of oxidation states, when there is an excitation of electrons to vacant orbitals, thereby you can form many more number of oxidation states. Clear, guys? So what is the answer for this one? Option B is the answer. Let's go to the next one. This is another theoretical question. Sorry, the question based on the reactions. Look at this one, guys. What would happen when a solution of potassium chromate, it's not potassium dichromate, guys, it is what? Potassium chromate. What will happen if a solution of potassium chromate is treated with excess of dilute nitric acid? So look at this one, guys. Question number 11. What will happen if the potassium chromate is treated with excess of dilute nitric acid? What is nitric acid? Nitric acid is HNO3. Already in HNO3, nitrogen is in the highest possible oxidation state. Means HNO3, it cannot get oxidized any further. So this is a very peculiar reaction, because here the potassium chromate, right, it will not be able to oxidize the nitric acid. So in fact, so in this reaction, right, what is going to be formed? We will be getting dichromate ion and water as the product. So what will be the products of the reaction, guys? Dichromate ion, Cr2O7 2- ion, and then water. So in the D block elements, we have to focus on the reactions of these, potassium permanganate and potassium dichromate, guys, because quite often in the previous years also they have asked questions on this. Okay, so let's look at the next question. The equivalent weight of MnSO4 is half of its molecular weight when it is converted into what? So we have to find out in which case the equivalent weight of MnSO4 is half of the molecular weight. Remember, guys, for these D block or F block or even some of the P block elements that show variable oxidation states, right, we calculate the equivalent weight based upon the reaction. Here in MnSO4, right, what is the oxidation state of manganese 2? So if we say Z is the change in the oxidation number, if we say Z is the change in oxidation number, right, then what is the formula? This Z is also, by the way, called as what, guys? This Z is what we will be calling as the valency factor, which will be changing from reaction to reaction. So what is the formula for the equivalent weight? Equivalent weight is equal to what? Molecular weight divided by Z. Okay, here what they are saying, the equivalent weight is half the molecular weight, means they are expecting the Z value to be equal to what? 2. So the change in oxidation number should be equal to what, guys? 2. Any responses for the 12th question? So when you see the change in oxidation state 2, here MnSO4, manganese is what? Plus 2. If you look at in MnO2, right, what is the oxidation state of manganese? Plus 4. So what is the change here? That's what we are looking for, right? We are looking for the change in oxidation state to be equal to what, guys? 2. So thereby we will have equivalent weight is equal to half the molecular weight. So for the compounds which can exhibit variable change in the oxidation states, then for them, right, the equivalent weight will change depending upon the reaction. What is the expression? Equivalent weight is equal to what? Molecular weight by Z. Z is the valency factor. So here what is the significance of the valency factor? Valency factor will be equal to what, guys? It is the change in oxidation number of the element. Okay, I think we are getting some responses. So what is the answer for this question? MnO2. So when the MnSO4 is converted into MnO2, the oxidation number is changing from plus 2 to plus 4. The oxidation number is changing from plus 2 to plus 4. Thereby the change in oxidation number is 2, and hence equivalent weight is equal to molecular weight by 2. Clear, guys? Let's go to the next question. Question number 13. Look at this one. I mean, here we are even getting some questions based on the coordination compounds. That's fine, because after all, these compounds are formed by the D block elements. Look at this question, guys. In which of the following transition metal complexes does the metal exhibit zero oxidation state? It's a straight textbook question, guys. In which of the following transition metal complexes the metal exhibits zero oxidation state? Question number 13. Look at this, guys. In all the others, whether you take B, C, D, the metal ion present, the metal atom present in the coordination complex, we can say the metal atom is present in the coordination complex, right? They will be in the form of ions. Here in B, if you see, right, it is Fe3+, assuming X is an halogen atom. In C, if you see in C, it is cobalt 3+ again. In D, it is what? Fe2+. Only in option A, nickel is in what oxidation state? 0. What is the compound, by the way, guys? 13th, nickel tetracarbonyl. Okay, I think there is a significance for this compound in the extraction, metal extraction also. So we will form nickel tetracarbonyl for the vapor phase refining of nickel. So nickel tetracarbonyl will be formed, and on further heating this can be decomposed to give back the nickel. Clear, guys? What is the answer for the 13th question? It is option A. Let's move on to the next question. Question number 14. Look at this one, guys. The oxidation state of chromium in the final product formed by the reaction between Ki and acidified potassium dichromate solution. Means we are looking at the reaction between what? Ki and K2Cr2O7, acidified K2Cr2O7. So we need to look at the reaction, guys, then only we will be able to answer these kind of questions. So sometimes, right, we may not just get straight questions like, what is the product. They can even, mix questions like this. Basically, if you know the reaction means, we will be able to answer this question. Look at this, guys. Question number 14. Any responses? Question number 14. What we need to know? The reaction between Ki and K2Cr2O7. Because in potassium dichromate, right, what is the chromium oxidation state? It is +6. In potassium dichromate, what is the chromium oxidation state? It is +6. Okay. So what happens, guys? In the reaction between Ki and acidified potassium dichromate, right, what will be the product? The product will have chromium in the +3 state. The product will have chromium in what state, guys? +3 state. The I- will be oxidized. Oxidized to what? I2. So the dichromate is oxidizing I-, and in turn the chromium oxidation state is going to be changing from +6 to +3. So check this one, guys. So what is the question they are asking? The oxidation state of chromium in the final product. So what is the answer for this one? Option B. In fact, this particular reaction, right, is also there in the NCERT textbook in redox reaction chapter. We use this equation quite often for the balancing. We have this as a solved example, balancing for the chemical equation using the oxidation number method or the half reaction method. Okay, so check this one, guys. Let's go to the next question. Question number 15. Which one of the following metals is found in gunmetal, monometal, Constantine alloys? Which of the metals is found in gunmetal, monal metal as well as Constantine alloys? So here, these common alloys and their composition, right, guys, we have to be clear. In fact, we do have a scope of getting those kind of questions also. So these alloys based questions, we can either put them in the D&F block chapter, or we can also cover them under the metallurgy chapter. Both places we can cover them. So here we have to look at what is the metal that is common for monal metal alloy as well as Constantine as well as gunmetal. Question number 15. Look at this, guys. Constantine, right? It contains copper, nickel. Constantine contains what? Copper and nickel. And monal metal also contains copper. gunmetal also contains copper. So what is the metal that is present in all of them, guys? It is copper. So copper is present in gunmetal, monal metal as well as constant 10. In fact, in our YouTube channel, right, we made a video just recently only on the alloys and their composition. Probably you can take a look at that. Okay, check it, guys. Next question, question number 16. Which of the following metal is leached by the cyanide process? Which of the metals is leached by the cyanide process? Leaching. Question number 16. Okay, so guys, the leaching cyanide process, right, it is for what? It is generally used for gold and silver. Used for the gold and silver, where we will form a cyanide complex soluble, and then we will use a relatively more reactive metal like zinc, where we perform the displacement reaction. Clear, guys? What is the answer for this one? Silver. So generally the leaching process, right, cyanide process or the leaching process is used for gold and silver. Look at question number 17. Which of the following finally gives a black precipitate with Ag plus ions? So means we have the anions, when they are reacting with Ag plus, right, they will form the corresponding salt. So Ag plus and SO3 will form what? Silver sulfite. Ag plus and Br minus will form what? Silver bromide. Silver bromide is what? Yellow color. So here this question is a theoretical question, guys. We have to know the colors. We have to know the colors of these complexes. Look at this one, guys. AgBr is what? Yellow color. Ag2SO3, right? Ag2SO3, it's a white substance, but it will change the color under the influence of light to purple and then finally to black. Ag2S2O3, right? Thiosulfate is a white precipitate, whereas the silver chromate is a brown red crystal. So look at this one, guys. Question number 17. What is the answer? Ag2SO3, right? Silver sulfite, which will be a white substance. On keeping it for a longer time, right, under the influence of light, it will be turning into purple and then finally into black color. So question number 17. What is the answer for this one, guys? Option A. So we also have to look at some of these so these questions are it's a chance questions, guys. So how much ever we are able to remember the color of these compounds, we have to be looking at it. Question number 18. Look at question number 18. Which one of the following characteristics of transition metals is associated with their catalytic activity? So this is a very fundamental question on catalytic activity or heterogeneous catalysis, because the transition metals, they act as heterogeneous catalyst. They will be catalyst for most of the gas phase reactions. They are themselves solid, but they catalyze the gas phase reactions or even reactions in solution. So that's what we call as heterogeneous catalysis. So which is the property? Is it because of their paramagnetic nature? No. Is it because the color of the hydride ions? No. It is because of the variable oxidation states. Why? Because they can combine with the reacting species as well as, they can leave them out. So once the product is formed, right, the ability of an heterogeneous catalyst is what? They will form an weak chemical interactive bond or linkage with the reactive species, and once the chemical reaction is over, the products will be able to release out. So why the transition metals are associated with the catalytic activity is because they can have variable oxidation states. So which means they will be able to, because the variable oxidation state, right, they will be able to attach themselves to different variety of the reacting species, and it is not because of the high enthalpy of atomization. So what is the correct answer for this one, guys? 18th is what? Option C. Their variable oxidation states is the reason why they will be able to show the catalytic activity. Clear? Let's move on to the next question. It's another straight theoretical question, guys. The oxidation state of silver in Tollens reagent. the oxidation state of silver in tolerance reagent. We have to find what is the oxidation state of silver in tolerance reagent. Tolerance reagent is what, guys? It is for the detection of the aldehydes. So look at this. What is the tolerance reagent? It is AgNH3 twice plus, means the oxidation state of silver here is what, guys? +1. Question number 19. Question number 19. Check this one, guys. What will be the oxidation state of silver here? It will be +1. In tolerance reagent, what is the oxidation state of silver? It will be +1. Check it, guys. Next, no, we even have, P block we will have mainly questions based on structure, but sometimes we can even expect structure based questions on the D block also. F block we will not have that many questions in that sense. F block, try to focus mostly on the questions related to the trends or the anomalies. But D block sometimes we can have questions on these structure based things also. Look at this question, guys. In K2Cr2O7, every chromium is linked to, they are asking, is it linked to 2 oxygen atoms or 3 oxygen atoms or 4 oxygen atoms or 5 oxygen atoms? So we have to comment on how many oxygen atoms each chromium is linked to. So this is a question we can answer by looking at the structure. Ashar Jan, you are really little bit early for the session. Okay. So look at this, guys. Question number 20. Question number 20 is what? We have to find out what is the number of oxygens the chromium is linked in K2Cr2O7. See, instead of saying it as K2Cr2O7, we can look at what will be the structure of this dichromate ion. What will be the structure of the dichromate ion? I think we are getting some responses, guys. 20, Shri Vidya and Trisha, a lot of you are saying option C. So what is the structure of dichromate ion? This is the structure of dichromate ion. Chromium, in between two chromiums there will be one oxygen. So there is an chromium oxygen chromium bond, and each chromium will be separately bonded to 3 oxygens. So this side 3 oxygens, this side 3 oxygens, and there is of course a chromium oxygen chromium bond. So look at this, guys. Overall, if you look at any chromium, right, look at any chromium, it is bonded to how many oxygens? 1, 2, 3, 4. Each chromium is bonded to 4 oxygens. Clear, guys? So the correct answer is what? Option C. So mostly in the D block, you have to focus on reactions of the chromium and manganese compounds, like potassium chromate, potassium dichromate, and permanganate, potassium permanganate. Then we have to look at the questions related to the color magnetic moment on the D block side. F block side we have to focus on anomalies or exceptions, and then the trends. So this is the the focus area we have to keep in terms of covering the D block and F block elements. Okay. In the next session, we look at the coordination complexes or coordination compounds, and after the coordination compound session, right, we'll have one session exclusively on all inorganic chemistry just based upon the reactions. Okay, we'll see in the next session.